Hey guys, so in today's lesson, we are going to talk about factoring. We're going to be doing factoring over some stages. So the first level that we're going to be talking about is the most basic form of factoring. For this lesson, you're going to need station 1 and you're going to need this factors pairs chart. It has all of the factors of numbers 1 through 100. You may not need to use it, but it's just there in case you decide. The first form of factoring is taking out our GCF, our greatest common factor. And when we say factor, in this case, we're meaning that a number is divisible by another number. So for instance, 3 is a factor of 15 because 15 is divisible evenly by 3. All right, so for our first example, we're going to be talking about factoring a GCF from monomials. And remember, a monomial is just a polynomial that has one term. When we are factoring monomials, we just want to remember that like goes with like. Numbers go with numbers, variables go with variables. So if we have multiple variables, the x's go with the x's, the y's go with the y's, and so on and so forth. So let's try our first example. So for part A, we want to identify the greatest common factor for each set of monomials. We have 15x to the third power and 21x. So let's first start with the numbers. The factors of 15 are 1 and 15 and 3 and 5. The factors of 21 are 1 and 21 and 3 and 7. The greatest number that appears in both sets is 3. So my numeric GCF for the two monomials is 3. For our variables, we just have x's here, so that's all we're going to focus on. My first term, 15x to the third power, we have 3 x's. In my second term, 21x, I only have 1 x. So when you're dealing with variables, you're asking yourself, what is the most amount of variables that I can take out from each monomial? So if the first set has 3, and the second set only has 1, that means I'm only able to take out 1x from each of the monomials. So my GCF is going to be 3x. So at this point, I would like you to pause the video and I would like you to try question B. For part B, we have 5x to the sixth power and 25x to the second power. We want to identify our factors of 5 and 25. All right, so for 5, that's pretty simple. All we have is 1 and 5. And then for 25, we have 1 and 25, and then 5 and 5. So our greatest common factor is going to be 5. Next, we have x to the 6 and then x squared. So I have 6 x's in my first term, 2 x's in my second term, which means the most amount of x's I can take out from both is 2. So my GCF is going to be 5x squared. So for our next example, we have 3 different monomials and 2 different variables. So remember, again, like goes with like, numbers go with numbers. Our x's will go with our x's and our y's will go with our y's. So for the numbers, we just have to identify the greatest common factor between 18, 45, and 90. I'm showing the factors on the screen, and we see that the greatest common factor between all 3 of those numbers is 9. All right, so now we got x's and y's, so let's deal with our x's first. In our first term, we have 3 x's. Our second term, we have 4 x's. And our third term, we have 2 x's. All right, so the most amount of x's I can take out is 2 of them, so I'm going to take out an x squared. All right, now we got to do with our y's. So in the first term, I got 2 y's. The second term, I have 1. And remember, if you don't see an exponent for that variable, that means there's an invisible 1 there. And then the third term, I have 4 y's. So the most amount of y's I can take out is just 1. All right, so leaving my GCF as 9x squared y. All right, I'd like you to pause the video and try to do the last example D on your own. So for question D, you should have gotten 10mn. All right, so moving on to example number 2. We want to factor by finding the greatest common factor. So this one is a little bit different, but if you are feeling comfortable with factoring the monomials, this one shouldn't be that bad. So we're going to be factoring these polynomial expressions by taking out the GCF. So we're going to be doing the opposite of distribution, okay? So let's look at our first example. We have 3x minus 18. So all of that is just one expression. So looking at my first term, I got 3x. My second term, I got negative 18. So remember, numbers go with numbers. Since my negative 18 doesn't have a variable, I don't got to do anything with the variables. I'm just focusing on the numbers. So the greatest common factor between 3 and 18 is 3. So I'm going to put the 3 on the outside. And I'm going to make a parentheses and I'm going to figure out what's left over from my expression. Okay, so 3x divided by 3 is going to get me x. And then negative 18 divided by 3 is going to get me negative 6. So my answer is going to be 3 parentheses x minus 6. And remember what I said, this is the opposite of distribution. So if I were to distribute that 3 into the x minus 6, I would get the original problem confirming that my answer is correct. Okay, so let's move on to part B. So I have this binomial here. So it's 12x to the second power plus 16x. Okay, so both terms have numbers, both terms have variables, which means I'm taking out both. So looking at 12 and 16, I see that my greatest common factor is going to have to be 4. And then my first term has an x squared. My second term has an x, which means I need to take out the most amount that appears in both, which is only 1. So I'm going to take out an x. So my GCF is 4x. Okay, so now I need to divide. Let's do with the numbers. 12 divided by 4 is 3. So I know the first term is going to have a 3 on the inside of my parentheses. And then x squared divided by x is just going to leave me with x. Okay, now I have my plus sign. 16 divided by 4 is 4. And then x divided by x just gives me 1. So I don't need to put an x there. So my final answer is 4x times 3x plus 4. And if I were to distribute that 4x, I would get the original problem, hence knowing that my answer is correct. Okay, so for part C, we have negative 10x squared minus 15x. Notice that my leading term is negative. Anytime that your leading term, your first term that has the biggest exponent is negative, it is best to take out a negative GCF. It is just going to save you a lot of headache when you move on to more advanced math, so get into the habit of doing that now. Between negative 10 and negative 15, my GCF is going to be negative 5. All right, remember, I'm taking out a negative because my leading term is negative. All right, so I have negative 5 as my numeric GCF, and now I need to look at the variables. My first term has 2 x's, my second term has 1 x, which means I can only take out 1 x. Now I need to figure out what's left over and just be very careful about the negatives. So negative 10 divided by negative 5 is going to get me positive 2. X squared divided by x is going to leave me with an x. Negative 15 divided by negative 5 is positive 3. And then the x's are going to cancel out, so we don't need to write that down. All right, so you should have a final answer of negative 5x times 2x plus 3. And if we were to distribute our answer, we will get the same problem, which makes us know that our answer is correct. All right, so for part D, we have a trinomial here, but it's the same exact step. So I would like you to pause the video and try to answer this one on your own. We see that our leading term is negative, which means that we need to take out a negative common factor. So looking at our numbers, we have negative 4, we have 8, and then negative 24. So the biggest number that I can take out from all three terms is going to be that negative 4. Looking at my variables, I see that my last term does not have a variable, which means we cannot take out any x's. So all of my variables are going to stay the same. So negative 4 divided by negative 4 is going to be 1. My first term is just going to be left as x squared. Then 8x divided by negative 4 is going to be negative 2x. Then negative 24 divided by negative 4 is going to be positive 6. Okay, so our final answer for this problem is going to be negative 4 parentheses x squared minus 2x plus 6. Cool? All right, example 3. So this one's going to look a lot different. We're doing the same process, but it just looks different. All right, so this one, first we need to identify the greatest common factor, and then we're going to have to simplify. So for part A, I have x plus 2 times x minus 1 and plus x plus 2 times 2x minus 5. I see that x plus 2 appears twice, which means that is my greatest common factor. So I'm going to pull out x plus 2 and put that in parentheses. And then I'm going to write what is left over. From the first set over here, I see that I have x minus 1 left over, right? And then I have a plus left over, and then I have 2x minus 5 left over. All right, so right now we should have x plus 2 in parentheses, and then another parentheses next to it, x minus 1 plus 2x minus 5. So in that second set of parentheses, we can combine like terms. So after you combine like terms, you're going to get x plus 2 and then 3x minus 6. And that's going to be your answer for this problem. Okay, so hopefully not too bad. For part B, it's the same thing, but the only difference is that we have a minus in the middle. So let's see if there's a common factor or common expression between these two terms. And I see that 2x minus 3 is repeated twice, so that is my GCF. So I have 2x minus 3, take that out, and then I'm going to write what's left over. All right, so what's left over, I have 3x plus 1. Then I have a minus, and then be very, very careful. Since I have a minus, that means everything that comes after the minus sign needs to be multiplied by that negative or that negative 1. So I'm going to put x plus 4 in parentheses. So now I have this, and I need to simplify the second part of my expression. All right, so first let's deal with that negative. Since I have that negative, that means I need to distribute the negative to the x plus 4. So let's rewrite our problem. So now we have 2x minus 3 in our first set of parentheses, then 3x plus 1 minus x minus 4. And then now we can combine like terms. All right, so your final answer should be 2x minus 3 times 2x minus 3. For the last one, I would like you to try this one on your own and then come back to see if your answer is correct. After you're done with problem number C, you should have gotten this as your final answer, x minus 1, then x plus 6. Okay, so that is all for station 1. And let me know if you have any questions.